1.6.4. Solving an absolute value inequality. Absolute value equations may not always involve equalities. Instead, we may need to solve an equation within a range of values. We would use an absolute value inequality to solve such an equation. An absolute value inequality is an equation of the form: the absolute value of A is less than B. The absolute value of A is less than or equal to B. The absolute value of A is greater than B. Or the absolute value of A is greater than or equal to B, where an expression A, and possibly but not usually B, depends on a variable x. Solving the inequality means finding the set of all x that satisfy the inequality. Usually this set will be an interval or the union of two intervals. There are two basic approaches to solving absolute value inequalities: graphical and algebraic. The advantage of the graphical approach is we can read the solution by interpreting the graphs of two functions. The advantage of the algebraic approach is it yields solutions that may be difficult to read from the graph. For example, we know that all numbers within 200 units of 0 may be expressed as the absolute value of x is less than 200, or negative 200 is less than x is less than 200. Suppose we want to know all possible returns on an investment if we could earn some amount of money within $200 of $600. We can solve algebraically for the set of values x such that the distance between x and 600 is less than 200. We represent the distance between x and 600 as the absolute value of x minus 600. The absolute value of x minus 600 is less than 200, or negative 200 is less than x minus 600 is less than 200. Negative 200 plus 600 is less than x minus 600 plus 600 is less than 200 plus 600. 400 is less than x is less than 800. This means our returns would be between $400 and $800. Sometimes an absolute value inequality problem will be presented to us in terms of a shifted end, or stretched, or compressed absolute value function, where we must determine for which values of the input the function's output will be negative or positive. How to? Given an absolute value inequality of the form, the absolute value of x minus a is less than or equal to b for real numbers a and b, where b is positive, solve the absolute value inequality algebraically. 1. Find boundary points by solving the absolute value of x minus a equals b. 2. Test intervals created by the boundary points to determine where the absolute value of x minus a is less than or equal to b. 3. Write the interval or union of intervals satisfying the inequality in interval, inequality, or set builder notation. Example 6. Solving an absolute value inequality. Solve. The absolute value of x minus 5 is less than 4. Solution. With both approaches, we will need to know first where the corresponding equality is true. In this case, we first will find where the absolute value of x minus 5 equals 4. We do this because the absolute value is a function with no breaks, so the only way the function values can switch from being less than 4 to being greater than 4 is by passing through where the values equal 4. Solve. The absolute value of x minus 5 equals 4. X minus 5 equals 4. X equals 9. Or x minus 5 equals negative 4. X equals 1. After determining that the absolute value is equal to 4 at x equals 1 and x equals 9, we know the graph can change only from being less than 4 to greater than 4 at these values. This divides the number line up into 3 intervals. X is less than 1, 1 is less than, x is less than 9, and x is greater than 9. To determine when the function is less than 4, we could choose a value in each interval and see if the output is less than or greater than 4, as shown in Table 1. Table 1. Interval test x. F of x is less than 4 or is greater than 4. X is less than 1. F of x is 0. The absolute value of 0 minus 5 equals 5 greater than 1 is less than x is less than 9. F of x is 6. The absolute value of 6 minus 5 equals 1 less than x is greater than 9. F of x is 11. The absolute value of 11 minus 5 equals 6 greater than. Because 1 is less than or equal to x is less than or equal to 9 is the only interval in which the output at the test value is less than 4, we can conclude that the solution to the absolute value of x minus 5 is less than or equal to 4 is 1 is less than or equal to x is less than or equal to 9, or open square bracket 1, 9, closed square bracket. To use a graph, we can sketch the function f of x equals the absolute value of x minus 5. To help us see where the outputs are 4, the line g of x equals 4 could also be sketched as in figure 11. Figure 11 x, f of x, f, g. The graph of f is below, or, on the graph of g. Figure 11. Graph to find the points satisfying an absolute value inequality. We can see the following. 1. The output values of the absolute value are equal to 4 at x equals 1 and x equals 9. 2. The graph of f is below the graph of g on 1 is less than x is less than 9. This means the output values of f of x are less than the output values of g of x. 3. The absolute value is less than or equal to 4 between these 2 points, when 1 is less than or equal to x is less than or equal to 9. In interval notation, this would be the interval, open square bracket, 1, 9, closed square bracket. A. Analysis. For absolute value inequalities. The absolute value of x minus a is less than c. Negative c is less than x minus a is less than c. The absolute value of x minus a is greater than c. X minus a is less than negative c, or x minus a is greater than c. The is less than or is greater than symbol may be replaced by is less than or equal to or is greater than or equal to. So, for this example, we could use this alternative approach. The absolute value of x minus 5 is less than or equal to 4. Negative 4 is less than or equal to x minus 5 is less than or equal to 4. Rewrite by removing the absolute value bars. Negative 4 plus 5 is less than or equal to x minus 5 plus 5 is less than or equal to 4 plus 5. Isolate the x. 1 is less than or equal to x is less than or equal to 9. Try it number 6. Solve the absolute value of x plus 2 is less than or equal to 6. How to? Given an absolute value function, solve for the set of inputs where the output is positive or negative. 1. Set the function equal to 0 and solve for the boundary points of the solution set. 2. Use test points or a graph to determine where the function's output is positive or negative. Example 7. Using a graphical approach to solve absolute value inequalities. Given the function f of x equals negative 1 over 2, the absolute value of 4x minus 5 plus 3. Determine the x values for which the function values are negative. Solution. We are trying to determine where f of x is less than 0, which is when negative 1 over 2, the absolute value of 4x minus 5 plus 3 is less than 0. We begin by isolating the absolute value. Negative 1 over 2, the absolute value of 4x minus 5 is less than negative 3. Multiply both sides by -2, and reverse the inequality. The absolute value of 4x minus 5 is greater than 6. Next we solve for the equality. The absolute value of 4x minus 5 equals 6. 4x minus 5 equals 6. Or 4x minus 5 equals -6. 4x minus 5 equals 6. X equals 11 over 4. 4x equals -1. X equals -1 over 4. Now, we can examine the graph of f to observe where the output is negative. We will observe where the branches are below the x-axis. Notice that it is not even important exactly what the graph looks like, as long as we know that it crosses the horizontal axis at x equals -1 over 4, and x equals 11 over 4, and that the graph has been reflected vertically. See Figure 12. Figure 12. X, y. X equals -0.25. Below x-axis. X equals -2.75. Below x-axis. We observe that the graph of the function is below the x-axis, left of x equals -1 over 4, and right of x equals 11 over 4. This means the function values are negative to the left of the first horizontal intercept at x equals -1 over 4, and negative to the right of the second intercept at x equals 11 over 4. This gives us the solution to the inequality. X is less than -1 over 4, or x is greater than 11 over 4. In interval notation, this would be open parenthesis, -infinity, -0.25, closed parenthesis, union, open parenthesis, 2.75, infinity, closed parenthesis. Try it number 7. Solve, -2, the absolute value of k, minus 4, is less than or equal to, -6. 1.6.5, Media. Access these online resources for additional instruction and practice with absolute value. 1. Graphing absolute value functions. http://openstaxcollege.org/l/graphAppsValue. 2. Graphing absolute value functions 2. http://openstaxcollege.org/l/graphAppsValue. 3. Equations of absolute value function. http://openstaxcollege.org/l/findicobsvel. 4. Equations of absolute value function 2. http://openstaxcollege.org/l/findicobsvel. 5. Solving absolute value equations. http://openstaxcollege.org/lsolveabsvalue.